Hello everyone, welcome to the video lecture series of complex variable. In this topic we shall be dealing with problems on analytic functions. In our previous video lecture we have seen what all requirements are there about the definition of analytic function, the Cauchy-Riemann equations, and the formula for the derivative. And now in this video we shall see some important questions based on analytic functions. So let us see the first one. This is a most popular and a very standard question which is across all the domains. Whenever the complex or the analytic functions, whenever you are dealing, you come across this. So the question is, show that f of z equal to e to the power z, the small z. Okay, it's a small z. E to the power z is an analytic function and also find its derivative. Now, this is the question that comes across most of the examination. This kind of basic question it is, but then again, it is a very important one. So, let us see how to handle. So, we first write down here, we consider a function f of z equals to e to the power z. Now, when we write down this, the first important step here is that we need to do this thing, that is, we put f of z as u plus iv and z as x plus iy. So the moment you do the following substitution, what do we do is, therefore u plus iv is equals to e to the power x plus iy. Okay, now what to do about it is, u plus iv is equals to e to the power x times e to the power iy. This is the basic rule of algebra, or laws of indices if we call it. Then you do this way. Now we have seen a very important formula. Let us recall that formula. The formula we had seen was e to the power I theta equals to cos theta plus I sin theta. Now in this formula, we, instead of theta, we have y over here. So let us use that formula and write down the further simplification. So e to the power x times, you have cos of y plus I times sine of y. Okay, we multiply them here, so we get e to the power x cos y plus e to the power I times e to the power x sine y. Okay, sine of y. So we have this. Now u plus iv. Now LHS is a complex function and RHS is also complex. So we have this another important kind of learning from complex numbers, that is, that if we call this here, if another, like a plus ib is equals to c plus id, if and only if. Okay, this is if and only if a is equals to c and b is equals to d. This is a very important rule. Two complex numbers are equal if the real parts and imaginary parts are equal. So here also the same logic gets continued, and we get here, it is u is equals to e to the power x cos y and v is equals to e to the power x sine y. Okay, this is what we get. Now we put this two important uh, de deductions here in the box so that we can use them when we want. Okay, so these are the two important ones. Now what we need to check is, we have found the real part and the imaginary part. Now we go for the checking. Over here is step 2. Step 2 is going to be to check that CR equations are satisfied or not. Okay, so let us do that. So we now know CR equations were, basically we have, first thing is ux. Okay, so ux is nothing but w by x. So we do the partial derivative with respect to x, we get e to the power x cos y. Okay, so when we do that, we will have cos y as constant and the answer will be e raised to x cos y. This will be the answer. Now uh, when we have ux, now we calculate uy. Uy is w by y, so it is w by y e to the power x cos y. So we get over here e to the power x is constant, we take the derivative of cos y, so derivative of cos y is minus of sine y. Alright, so this is the derivative over here, and so final answer here we have is minus of e to the power x sine y. Okay, that is the derivative here. Again we calculate here vx. So vx is nothing but dabba v by dabba x, so that is going to be partial derivative with respect to this one. So when we calculate here, it is going to be sine y is constant and e raised to x derivative is e raised to x, so answer is e raised to x sine y. Okay, that is the derivative. Then now we calculate vy. Vy, when we calculate, it is going to be dabba v over dabba y. Okay, so when the partial derivative is calculated, we will get over here is e to the power x times sine y. So e to the power x is constant, derivative of sine y is cos y. Now we got four answers over here, so let us label them. So from 1, ux is vy, from 1 and 4 we get is u suffix x is v suffix y, and from 2 and 3 we get, we can see that uh, uy is nothing but the negative of vx, right? If we have a negative sign in vx, we will have that. So this is negative over here. So this means, therefore we can say now that, therefore this implies, therefore Cauchy Riemann equations, CR equations hold. Now regarding continuity, or equations hold or are satisfied. Okay, equations hold. So now then there is one more step here which I'll write here. We have to now go for the definition of analytic function. Said that the function, there were necessary and sufficient conditions. So the necessary condition was that Cauchy-Riemann equation should be satisfied. So here they are satisfied. Now we go for the condition that is sufficient condition, that is the continuity. Now we give this kind of argument which is very simple, because many students get confused with continuity and all that. So let me give you a simpler way of handling this. So the thing is like this. I'll write here in the next part. Over here what we do is we say e to the power x sine y cos y. Okay, e to the power x sine y cos y. These are continuous functions. Okay, these are continuous functions. Therefore ux, what we had got over here is e to the power x cos y, right? E to the power x cos y uy, which is minus of e raised to x sine y, are continuous functions. Hence the partial derivatives ux, uy, vx, vy are also continuous. Therefore the function f of z equals to, the function was e to the power z is analytic. Okay, is analytic function. It is what we got. Now we go for finding the derivative. So let us see how to find the derivative. Let us see how to handle it. We have the formula f dash of z is equals to ux plus ivx. When I say ux ivx, I mean the partial derivative. Okay, so we have already taken that formula. So what happens is here is we have found ux as e to the power x cos y and I times e to the power x sine y. Okay, now we write that, and then e to the power x can be taken common, and then we have cos y plus I sine y. Again we use the formula that cos y plus I sine y is e to the power iy. We can use that e raised to x times, this will become e to the power iy. So further when we simplify, we get e raised to x plus iy. But x plus iy, we had already substituted this as z, right? We can use this as a substitution for z. So this is nothing but e raised to z. So therefore at the final stage what we have is f dash of z is equals to e to the power z. That's the derivative. Okay, so this formula works, and this is how it is done. So this is one very basic example regarding how to calculate the derivative using the analytic function definition and concepts. Okay, so this is one example. Now I'll see you with another example of similar kind with a little slight more complexity. Try to digest this example, try to understand the argument the way we are trying to tackle. So this is under the heading of analytic functions that we are learning, and what we need is the basics that we have done. Continuity, I don't expect students to write all the details of continuity and show them, but we can have this kind of argument because e raised to x sine y cos y, all these are continuous functions, so their product is continuous, their addition is continuous, and so that's why we took up this argument. So they are continuous functions, therefore the partial derivatives are continuous, hence we have the criteria necessary as well as the sufficient criteria both are satisfied, therefore the function e to the power z is analytic. Now this is how we calculate the derivative. So I hope you like the content of the this video lecture. Please share it with your friends, do hit like button and subscribe to my channel, do hit the bell button too. I'll see you with the next in the next video lecture with more complex problem. uh, Thank you for joining in. Stay tuned, keep solving good amount of mathematics.